Greetings, this is Mr. Caslin. Today we're going to talk about sequences. I was working this out a little bit earlier. Okay, so a student and I were looking at the following sequence. And we were confused because we thought the problem was asking us whether it was a geometric sequence or an arithmetic sequence. We weren't actually finding it to be either, so let's look at this for a second. Okay, remember sequence of numbers. The dot 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 means this pattern is going to keep on continuing. All right, the first number in the sequence has a position. We call that position n. So n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, and so on. Okay, if it's an arithmetic sequence, or some people call it an arithmetic sequence, you would take the second number in the sequence, subtract the first, and you find the difference of those two numbers. Now remember, these are fractions. You have to find a common denominator. So you'd have to say 7/10 minus 12/10. Okay, is a negative 5/10. Okay, reducing that fraction, it's basically negative 1/2. All right, so the difference between these first two numbers is negative 1/2. Okay, let's look at the difference in the second two numbers. Again, you have an 8/15 minus a 7/10. You need a common denominator to do this. It looks like a 30. Okay, so what? You'd have 16 over 30 minus 21 over 30 gives you a negative 5 over 30. Both the numerator and denominator have a common factor of 5. So basically the common difference here is negative 1/6. Okay, so not an arithmetic sequence. They do not have a common difference between those consecutive numbers. Okay, so let's talk about geometric sequence. Remember, geometric sequence, you'd be using a multiplier to hop from one number to the next. That number can be greater than 1, or that number can be less than 1. All right, so a way to check to see if they have that common multiplier or common ratio would be to take the second number and divide it by the first number. So you take 7/10 divided by 6/5. Okay, fraction math, what you're doing when you're dividing two fractions is, remember, you can do a keep, change, flip. You're going to get what, 35 over 60? Those have a common factor of 5, right? So I believe that's 7/12, which is equal to, if you did this with a calculator, you'd get a decimal of 0.583. Okay, so the common ratio between these two numbers is 0.583. All right, now if you divided 8/15 divided by 7/10, you'd work through the same process. You'd get when I worked this out, I think I got a 16 over 21, which is I believe is 0.762. Okay, so not a geometric sequence either. But there is a pattern going on here. It is a sequence, and it's a pattern, and we can pretty much figure out what the next number is. So let's just describe this sequence that's going on. Probably the easiest way to do that is, let's get our notation a sub n. So any number in the sequence, where n is the sequence number, is equal to what? Let's base it off of the sequence number. Okay, how do I get from the sequence number to the numerator? 1 to 6, 2 to 7, 3 to 5. It looks like I'm taking the sequence number n and I'm doing what? I'm taking the sequence number and I'm adding 5 to it. Okay, so if I was the fifth number in the sequence, looks like that would be 10. That looks like that pattern holds up. Okay, now how do I get from the sequence number to the denominator? 1 to 5, 2 to 10, 3 to 15, 4 to 20. It looks like I'm taking the sequence number and I'm multiplying it by 5. Okay, so this sequence has, it's not arithmetic or geometric because you've got an addition involved and a multiplication involved. Okay, but there's still a pattern, n plus 5 over 5n. That's probably the simplest way to describe this. There are other ways using recursive and whatnot. Okay, so what happens in our fifth number in the sequence? You get a 10 over 25. And you'd reduce that to what, 2/5? Okay, what's nice about sequences, describing them with mathematical expressions, is so that you can figure out the values of numbers that are very large. Okay, you don't have to sit here and do this 100 times to find n is equal to 100. Okay, plug it into your formula. So if the 100th number in the sequence would be 100 plus 5 is 105, and then 5n would be 500. Both of those have a common factor of 5, so you can reduce that fraction. What's even nicer, this can be put into a computer program, and now you have something that can, all you have to do is enter the value of n, and it will give you the nth number in the sequence. Okay, so it doesn't look like this is arithmetic or geometric, but it doesn't mean it is not a sequence. It is a sequence, and we can describe it with a mathematical expression. All right, have a good day.